Hello, I'm Alex Brown, and I'd like to introduce you to the Floor STC-IIC Acoustic Analysis Design Tool. This tool helps architects and engineers quickly determine the sound performance of their floor assemblies with varying flooring and ceiling treatments to calculate an expected sound transmission class and impact insulation class. Let's jump in. So this tool was built to quickly verify that the selected deck and the slab that are probably pre-selected for structural purposes will work with the selected flooring and ceiling options and give you that acoustic performance you're looking for. So starting at the top, working our way down, job name and description can be inputted up here. These will be incorporated into the file name of the PDF that you can download. So it can be helpful to organize different areas or different projects if you're using this tool repeatedly. And then starting at the top here for flooring, this is going to include luxury vinyl tile, carpet, hardwood. The different options that we tested are all here. These are the different Vulcraft and Verco deck types that are available across the country. If you're not immediately sure which one would apply to your area, we've got a map here just showing kind of that breakdown. Vulcraft has sort of everything east of the Rockies, Verco, everything west. And then the ceiling, again, kind of like with the flooring, we've got different options here depending on what that build out is going to be for your tenant. And then as you make changes, these values over here for the STC and IIC will update immediately. So you can see kind of a quick example here. The graphic also updates. So that's going to incorporate every layer of this from the deck to the flooring to the ceiling. We've got graphics just to kind of quickly confirm that you're getting what you think you're getting. And then those performances update over here. And then at the very bottom of the tool, we've created this generic rating scale just to identify what the different ranges of STC or IIC values are and kind of their real world description that would describe how that performance is. And then again, this print button here will take everything that's inputted and shown on the screen and put it into a downloadable PDF that will summarize everything as well as describe some of our methodology. So we'll look at that in just a little bit. But first, I want to start by trying to find the worst performing floor assembly possible. So if there was nothing as far as flooring, it's just bare concrete on top. And we can use the thinnest slab possible. So we'll do an 1.5 inch composite deck here, lightweight concrete with the minimum amount of concrete cover. So you can see my numbers over here updating accordingly, and then no ceiling whatsoever. So with that, my STC is 46 and my IIC is 17. So the 46 isn't horrible. 50 is generally code minimum, but that IIC of 17 is absolutely terrible. You would hear everybody walking above you. So let's improve on that. We can throw some flooring in. So just some hospitality carpet. And that already has improved our IIC quite a bit. STC stayed the same. So let's put a hung ceiling in there. So just a dropped gypsum board ceiling. And with that, my values are much better now. So 53 and 56 respectively, both getting over that 50 hump. And let's say I was completely happy with this design, wanted to proceed. I would hit this print button here. And that downloads a file with job 1, area 1, just pulling from the top text bars here. And if I open that up, you can see it summarizes all of my inputs and then my output, STC of 53, IIC of 56, hospitality carpet, that deck slab, the hung ceiling. And then what's really interesting, we've actually predicted the performance of different frequencies within this assembly. So you can see that graphed here and in chart form. So this is for the STC performance, and then this is for the IIC performance. And then there's a little bit of language here as well, just describing how this tool works. Because we didn't test every single possible assembly, there would be thousands of them. What we did was calculated expected performance with an engineering analysis based on 108 tests spanning the full range of input parameters. This model has been shown to predict STC and IIC ratings with an average difference close to 0 and a standard deviation of less than 2 for STC or 3 for IIC. And further engineering and analysis can be accessed here. So this comes from our outside sound consultant. They wrote this really good report summarizing our methodology, how the research was done, and then how the tool was built. And I'd really like to point to the section 2.2 here. because this really speaks to why the tool even exists in the first place. International Building Code provides 2 ways to demonstrate a building's assembly meets the requirements. The first is to simply test the assembly. That's great. The second way is to establish the STC and IIC rating by engineering analysis based on a comparison of data of walls and floor ceiling assemblies. The tool described in this study is limited to concrete and metal deck composite slabs, but even for this limited subset of assemblies, there's a wide range of possible assemblies. So the type of deck, type of concrete, thickness of concrete, finished floor, ceiling conditions can all vary, and the total number of permutations is in the thousands, which is clearly impractical. An engineering analysis is required to establish these ratings in a way that's consistent, realistic, and defensible. So that's sort of the philosophy behind this tool. If you wanted to go deeper and see the actual test data for those 108 tests done, contact your local district office and they'd be able to point you in the right direction on that. And that's the Floor STC-IIC Acoustic Analysis Tool. It's a powerful tool to quickly analyze different combinations of flooring, structural deck slabs, and ceiling options and dial in your next project's acoustic performance. And with that, happy specifying.